Arthur, do you want to start? Do we want to give it a few more minutes?
I can start whenever. I mean, so I don't know how many people we're expecting, but I'm happy just to jump right into things if that's all the same with you.
Yeah, so I don't know the exact numbers. I think more people will join, but we can start. So everyone, thank you for joining this session with Arthur K. He know how to introduce himself, so I give him the stage. Yeah, we can see you.
Thank you. Yeah, I'm gonna move my camera over here. Hopefully that.
Yeah, we can see you perfectly.
Thank you.
You.
Better. Awesome. Yeah. Thank you, Ori, for allowing me to speak today. I'm going to share my screen simultaneously while I talk, and I'm going to be jumping through a couple of slides, but mostly doing some live coding along the way and doing a lot of things here in the browser. So yeah, thanks for having me today. If you have any questions along the way, feel free just to drop some things in chat. I'm going to try to keep that chat window open. And Ori, you may have to tell me at any point if there's something that I need to stop and address. We'll probably also take a quick restroom break, maybe at the top of each hour, just to give everyone a chance to stretch their legs. I know this is going to be a fun 3 hours, but we should have some fun here. So welcome to your introduction to hacking web applications. And I wanted to start today's presentation with a interesting fact. According to a survey done in 2017 by the group Security Intelligence, 94% of web applications suffer from high severity software vulnerabilities. And I'm happy to share this link out either in the chat, or you can look this up yourself. But the interesting part about web application security is that most web applications that you'll find in the wild do have some sort of software vulnerability. That doesn't necessarily mean that the application itself is vulnerable to attack, but this is a good discussion point for us as we begin our journey into learning about web application hacking, because what we'll find is the more items we discover about an application that we find to be vulnerable, we'll begin to piece together different pieces to the puzzle, so to speak, so that one puzzle piece by itself doesn't necessarily mean that you're going to be able to hack in and own any given web application. But when you start to put multiple pieces together, you get a much more clear picture of how the application's built, the correct way in which to attack that application, and probably most importantly to the event today would be how to mitigate those vulnerabilities so that our own applications cannot be hacked. So I hope that that's the large takeaway from today's presentation. For a quick introduction of myself, my name is Art. I am a web application developer living in the United States near a city called Chicago, for those of you who may not be familiar. I do work in a freelance capacity, and you can check out my website, which is akawebdesign.com. You'll also find me on social media, namely Twitter. My handle is Arthur AK. And if you have any questions about today's presentation, later today, next week, next month, at any given point, please feel free to reach out to me. I can always make myself available. And this is a topic that I feel particularly passionate about, is hopefully you'll find out today. Before we jump into anything important, it is imperative that I point out what we're about to learn today has legal implications for you. And here in the United States, at least, I'm not sure what the laws are in the various locations that some of you may hail from, but I know that in the United States, you cannot attack an application without the expressed written consent of the owner of the application. Meaning that if you, if you're working for a company and you're developing a web application and you want to test that application for vulnerabilities, you not only have to get the expressed written consent of your supervisors or perhaps the board of directors, anybody who's in a position to say that they have ownership of that application, but this also extends to the infrastructure on which you might be testing. And so, as an example, if you're hosting your application, let's say in Amazon Web Services, AWS is typically very lenient about allowing anybody to test the infrastructure running in AWS. But if you were, let's say, running your application on a shared server through a company like GoDaddy or DigitalOcean, more than likely, they are not going to allow you to do this. So it's very important that you understand the gravity of what we're about to embark on. And to say this more succinctly, if you aren't sure if you're allowed to do something, please err on the side of caution and don't, because the legal authorities in whichever country you may hail from are not going to take this lightly. So please keep this in the back of your mind at all times as we move forward. What I'm going to teach you today should be a lot of fun, as long as, again, you're not doing these things outside the bounds of your legal jurisdiction. So the agenda for today is broken down into 3 major sections. So in this first hour, we're going to learn to think like a hacker. We're going to start from the bare bones basics about how websites work. And this may be a review for a lot of us on the call. For others, it may be a really refreshing introduction. So if you feel like it's starting slow, please be patient, because we're going to move very quickly into some more detailed points about how your browser dev tools work. And we're going to go into some very fun examples about how to use these basics to start enumerating an application that we might want to hack into. The second hour, we're going to spend doing some manual hacking against a tool called the OWASP Zap. And I'm hoping that some of you have had the opportunity to deploy that either locally or onto Heroku ahead of this session. And if not, we'll be able to do that very quickly. And last but not least, we're going to be using the third hour to explore a tool named OWASP Zap, the Z attack proxy. And again, if you haven't had a chance to install that yet, I'd encourage you to do that during one of our breaks. Again, won't be a big deal. It takes only a couple of minutes to do. But we're going to learn about how to automate some of the things that we are going to start by doing manually in that third hour. So let's begin by talking about what a hacker is going to think about when they're looking at a web application. The diagram that you see here on the screen comes from the National Institute of Standards and Technology here in the United States. And this diagram is equally applicable to hacking web applications as it is to doing things like network penetration testing. General idea is that we have 2 distinct phases of an attack. The first phase is what we call the discovery phase, in which we are literally learning as much as we possibly can about our target. And most attackers, especially if they're an advanced sufficiently trained and advanced hacker are going to spend upwards of 70 to 90% of their time attacking your application, just learning about your application. So you won't even necessarily know that they are looking at your application or on your network. They're just lurking in the background, looking at every nut and bolt that goes into your application. Once an attacker feels like they have a sufficient amount of knowledge to make an educated guess about attacking your application, they're going to attempt to gain access. And then, assuming that they've been successful in gaining access, they're going to attempt to escalate their privileges on either the application or the machine or the network. So you can think about this like they may get user level access to your application. Maybe they've registered for an account, or maybe they have found a low level user's credentials somewhere. And they're going to try to escalate those privileges up to, let's say, some sort of administrative level access. At which point they're going to begin enumerating the application again. So this is a cyclical process where they want to learn more about the application once they have escalated privileges before they try to further attack the application. And they may install various tools along the way to do some of these tactics. So this is how we are going to think about attacking a web application in today's presentation. We're going to spend lots of time doing discovery and then slowly begin to incorporate the attack phase as we've learned enough over time to make those educated guesses. So let's begin by discussing web technology at large. Every website that you browse using your internet browser, the browser that I'm using right now, Google Chrome, even though I'm showing you Google Slides, everything in here is built using HTML, CSS, and JavaScript. There is no compiled code, meaning there's no C or C++. There's no Python running here in my browser. Everything you see on the screen is generated using these three languages. And we're going to illustrate this by jumping directly into my IDE. I'm using Visual Studio Code. And we're going to start building a very rudimentary website. So let's say we start with an HTML file. And if you're unfamiliar with HTML, what you'll notice is that this is a highly structured markup language. In fact, that's what the HTML acronym stands for, Hypertext Markup Language. And this markup language describes the content that we're going to see on the screen. So I could put into, let's say, a paragraph tag, the words hello world, and maybe put a button on the screen that says click me. And saving this, and let's say I fire up a web server to run this file locally. Server PHP, I'm just running on port 9999. And I named the file test.html. So we can see here on the screen that what I have is hello world written on the screen and a button that says click me. So HTML in and of itself is a fairly basic programming language, but it's important to understand how it works. So every tag that goes on the screen describes some element. In the case of what we did here, we used P for paragraph. We used button for a button. If we wanted a link, we could put an anchor tag, which may have a link to some resource that might be outside of our control. For example, google.com. And we can encapsulate this in a word for some link text. And if I refresh the page, we'll see there is our link to Google. Clicking on it takes me to google.com. So HTML is fairly straightforward. Let's say that we want to explore what CSS has to offer. So we'll call this style.css. And style is an appropriate name because CSS, the acronym for cascading style sheets, is a language that will describe the presentation of those HTML elements. And so we could say in here that any paragraph tag. So we notice a P for paragraph is the same P that we used up here in HTML. That might, I don't know, let's say we want to change the color of the text from the default to red. And any buttons that we have, we want to give them extra padding. Let's say we want those buttons to always have 20 pixels of padding. So I can save this. And then in our HTML file, I'm going to create a header with a link to our style.css. And this is of type text CSS. And I believe if I refresh the screen now, oops, what did I do? I love live coding. It's very early in the morning here in the United States. I apologize. Include CSS file. What am I doing wrong? I am. Let's see here. It's the style tag link rel equals style sheet. Here we go. And coming back to here. There we go. Now we have the red text around our paragraph, and we have the 20 pixels of padding around our button text. Last but not least, in this triumvirate of files, we've got, let's say, a script.js file. And JavaScript is a language that allows us to control dynamic interactivity for our web application. And one example might be if we wanted to add an event of some sort when we click on the button. So what we might say in here is we want to create a variable called button that we have to grab out of the document. So we can do this using commands like get element by tag name, button, and we'll say button.add event listener, click, and this will take a function, or we could say alert that it was clicked. And we'll include that at the bottom of our HTML body. So the script source equals script.js, type equals text JavaScript, save and refresh this. And if I've done everything correctly, which I don't believe I have, we should have gotten an event listener happening on that. And events listener. And if this doesn't work off the top of my head, let's just do a different, let's just alert now. why that's not being included on my file, but I think you understand the idea. I'm just going to move on. My coffee is not setting in yet. So JavaScript controls the runtime of the app. You know what I'll do? Let's try adding this directly inside of a script tag here in the body. We'll force it to include. Oh, that's weird. I should definitely be in there now. All right, well, technical difficulties. Moving on, let's talk a bit about the kinds of applications that we're going to expect to see in the wild. There are two major kinds of web application architectures that we are going to find in the wild. The first is what we would consider some sort of server-driven application, where even though we've got HTML, CSS, and JavaScript being rendered to my browser right now, the server-driven web applications have a different language running on the web server, which will generate this HTML, CSS, and JavaScript at runtime. Rather than serving up raw files in the way that I just demonstrated. So, an example of this might be if we change this test HTML. If I rename this to, let's say, test.php. Inside of here, what I might choose to do would be to add some PHP code. That could do any number of things. In the real world, there might be some business logic in here that might check for whether or not a user has already been authenticated into the application. There might be other business logic that would say, you know, depending on what page a user came from, we might need to display a set of breadcrumbs on the page differently than if they came from somewhere else. There might be any number of use cases to have some server-side code in here, but the important thing to remember here is that the code inside these PHP tags is not going to be visible to the user in their web browser, but it can change the way in which the application renders. So an example here, we could say, if I were to up here create a variable, let's say, you know, var name equals, click this button, and then down in here, say echo name, save that, and my PHP is a bit rusty here. See if this works. This may not work. Okay, so I have a PHP error. The example should stand, though, to say that the code that's here in our PHP block that would get executed down here in our button is not visible to the user in their web browser. So a server-driven application will have all sorts of code that we will not be able to see doing our enumeration or discovery phase of our web application hacking. Whereas an application that is client-driven, again, going back to the previous example that we had, where this is purely an HTML file. And so I will leave this as a PHP extension, but a client-driven application will have static HTML, CSS, and JavaScript assets that then reach out to an API to dynamically insert elements into the HTML page at runtime. So this is a more and more common application architecture, and the OWASP Juice Shop that we're going to see here in just a little while is one of these client-side driven applications. So it's very important to understand the differences in application architecture as we begin to enumerate our applications, so that we can understand the various attack vectors that are going to be available to us at that point. So let me pause for a second. I see there were two questions in the Q&A. The first was, how can we contact me? For that, you can go to my website, which is akawebdesign.com. And this will take a second to pull up, at which point I have a contact link here. So you can click that, fill out the form, send me any messages that you want, and I'll be happy to respond. Second question was, how do we download OWASP Zap? And you just search for OWASP Zap. You'll get a link to the page here, and that second link, zapproxy.org, where you can click download now, and then depending on your platform, you can download the installer. The other thing that we're going to be getting into here in a minute, because I have a feeling this question will be coming as well, is OWASP Juice Shop. And if you click on the GitHub link and scroll down, you can deploy that to Heroku, which is the mechanism that I'm going to show you here in a little while, or you can run it from Docker or any other number of ways to do things. I think it runs Node.js. So if you just want to clone the repo and do an npm install, you can do that as well. So I'll come back to this here in a few minutes, but those are the resources that you are going to need. Okay. At this point, I'm going to pivot into three quick things that I want to point out about HTML, CSS, and JavaScript before this sounds like I'm beating a dead horse. Of the three languages that we just covered, you might be asking yourself, okay, this is really basic information. Why are we spending so much time going over this? How are they important to hacking a web application? JavaScript seems like the clear winner in terms of things that should catch your attention between HTML, CSS, and JavaScript, because JavaScript focuses on the interactivity of the web application. And if we're looking at a client-side architecture, again, meaning that we've got static HTML, CSS, and JavaScript that are reaching out to an API to then dynamically change what happens on the screen, JavaScript is handling all of that for us. So JavaScript is going to be very, very, very important to us. HTML clearly is describing what's on the screen, but we really aren't going to be able to change much of the rendered HTML unless we're interacting with a server-driven application. So if we've got a PHP extension like we do in the browser, and in the example that I was attempting to demonstrate, where we would set a PHP variable and then echo that onto the screen, HTML is going to become an attack vector for us in a server-driven application. CSS is kind of this this odd man out where it is very unlikely to be an attack vector because it doesn't deal with a whole lot of interactivity outside of perhaps some animations that happen on the screen. And it typically isn't a server-driven resource that's going to change based upon the way in which we navigated to a page, or change based upon our authenticated or unauthenticated status. But there have actually been proven some CSS attacks. This is one of those. It's possible in theory, though super unlikely to ever be something you find in the real world. Almost guarantee you'll never find this in a capture the flag situation, for those of you who might like things like hack the box. So know that there are methods that are theoretically possible for attacking CSS, but you're just super unlikely to ever run into them. When it comes to JavaScript, something that we do want to keep in mind is what we call sub-resource integrity, where in the example I was demonstrating here, where let's say we are pulling in a resource from our local server, sub-resource integrity is probably less important because we already control this style.css file. It's hosted on our server. So any attacker who wanted to abuse this would have to already have access to our network. But if we were pulling this from a third-party resource, maybe off of a CDN like Cloudflare, then we might run into some issues where if we couldn't guarantee the integrity, if we couldn't trust the validity of the resource that we're linking to, that would be a problem. Meaning that if we linked to John Doe's website and John Doe got hacked, that could have negative implications for our application. And so if you do a Google search for sub-resource integrity, you might run into an article like this where it talks about this topic in great detail and recommends that we do things like add an integrity hash to our script tag so that the browser will know and protect us if the resource that we request has somehow changed and our application is either unprepared for that change, or in the worst case scenario, that there's a malicious change that's happened to the resource that we're requesting. So if you're an application developer, I would highly recommend that you do more reading about this. If you're simply interested in hacking applications, this is yet another attack vector that we might consider. So just be aware of that. Last but not least is the concept of a content security policy, which can be attached to an application in one of two ways. Number one might be through the server's HTTP response headers, or we could add a meta tag into our HTML document. And the content security policy describes what things the web page is allowed or not allowed to do. And as an example, we talked about linking to third-party resources. If we didn't want our application to allow scripts or styles to be loaded from a third-party resource, we could put a very strict security policy onto our document that did not allow that. And content security policies are definitely an area in which that attackers have found vulnerabilities and hacked these things in the wild. You frequently see content security policies in capture the flag challenges. So again, something for additional self-study. We don't have quite enough time today to dig into all the nuts and bolts here, but this is yet another area that can help protect our web applications, but is also an area that we should look at while doing the enumeration on any web application. So we know if we're able to get a script to load onto a page, can we get that script to load other scripts from other domains? So let's jump back to our localhost example here. And let's start talking about our browser's developer tools. These are tools that are embedded into every browser. If you're a web developer, you probably know these really well. But if you're not, you right click on the page and you go down to the inspect menu. And depending on how you have things configured, this might pop up from you on the bottom of the screen. I have it configured to pop out from the right-hand side for me. And what we're going to find is that we have lots of options when it comes to exploring the nuts and bolts of our web application. So let's start with the Elements tab. What we're going to find here is that all of the HTML that was in the raw HTML document is visible here on the screen, and we can interact with it, and we can even see the styles that are applied to it. So we can see that from our style.css file is the color red. Let me make that a little bit bigger for everybody. So the Elements tab is a really interesting place for us to be. Number one, because if this is a client-driven application, again, that client-side architecture being static files served to the browser, and then JavaScript loads a bunch of things dynamically and changes the HTML on the fly. What we're going to know is that the elements inside, of this Elements tab are potentially different than what we see if we right click and go to view source and view the raw source code for the file. And we can already see this in effect where in the raw source code, my body only has a paragraph, a button, an anchor, and a script tag. What we'll notice is that here in the Elements tab, we have a few other things that exist. These are injected dynamically by my Chrome extensions. So when we are enumerating an application, it will be important to, number one, always view the raw source code, but it will also be equally important to look at the dynamic elements on the screen because these might change at any given time. In the JavaScript console, here we go. It tells me I did in fact have a JavaScript error here. Apparently, I was trying to add an event listener to something that I shouldn't have. But here in the JavaScript console, we can find messages that might be output by the developer. As an example, let's say come down here and let's go above that runtime error. Let's do console.log hello world. Refresh the page. We'll see that hello world is now output here in our JavaScript console. I can also interact with the page all I want to directly from this JavaScript console. So this is a really good way for us to test things that we think might be vulnerable without having to actually save files and get them onto a server. The Sources tab is going to allow us to view any JavaScript loaded by the page. And so we can see it's going to include a PHP file because it has my script tag. If I had any raw JavaScript files loaded here, it might load those as well. You can see it's also got our CSS files. It is going to allow us to explore other things like whether that source code has been compressed and obfuscated. We're able to set breakpoints in the JavaScript code so we could step through functions. We're going to do all of that here in a little bit in the OWASP Juice Shop. But just to keep moving along here, the other couple of tabs I want you to really get familiar with are the network tab, which is going to show us any and all files that are loaded by this application. So we can see the raw test PHP, and it'll give us a preview, but we can inspect all of the headers, including our response headers, our request headers. If there were any parameters sent via, let's say, like a post request, we'd be able to inspect those. And this is cool because we can right click and copy these commands, let's say as a curl command, which I can come back into my terminal and copy and paste. And that's going to fail because I don't have my server running, but let's start another terminal. And now paste that, and we'll see it requested the resource and the server responded with the raw code. So the network tab in Chrome DevTools is incredibly helpful for doing all kinds of things just like that. The application tab in Chrome, I think that this may be named differently in Firefox or Microsoft Edge or Safari, but the application tab allows us to inspect things like local storage, session storage, IndexedDB, or any cookies that might be stored by this application. So this is absolutely something we're going to look at every time that we do enumeration on a web application. There's a few other things in here as well, like performance, memory, Lighthouse. Security seems like it would be something super interesting for us. This is really more like recommendations as a developer, but this could be a place where you'd find things that might point you to do further enumeration on the website. Like it's unlikely to tell you that there's a password stored in a comment in some file, but it is likely to tell you that in this case, I'm not serving using HTTPS, which already means that this application could be vulnerable to some sort of communications interception. You get the idea. From here, I'm going to show you a couple of Chrome extensions. And again, these extensions can be used in other browsers as well that are going to further help us do some enumeration. And then we're going to do a quick example of how to put all of what we've just covered here in the last couple of minutes. We're going to put all of these skills to use. So the three Chrome extensions I want to talk about today are, number one, it's a tool called Wapalizer. Wapalizer is a extension that is going to inspect all of the things happening on a web page and tell us, what's being used to build that web page. And so in this case, we can see we're using PHP. This example is probably not too interesting because there's not a lot on this page. But let's go to, let's say, Troy Hunt's website where I showed you this sub-resource integrity article. And we click Wapalizer here. It can tell us all kinds of things that you might not have thought about or thought to look for. Number one, that it's running Google Analytics. It's running a CMS called Ghost. It uses a comment system called Discuss. It uses Node.js under the hood. If we try, let's say, the Mozilla Developer Network, this is running Google Analytics and something called Prism. If we go to Google Slides, it doesn't actually detect anything here, which is interesting. You kind of get the idea that Wapalizer will help us to enumerate the technologies being used, which can go a long way for us to doing that enumeration on figuring out how this application might be vulnerable. Another Another example might be, I'm going to pull open one of my own websites. Let's do Secure Web Solutions. And if we run Wapalizer, it'll tell us it's running React, but it's also going to tell us things like versions. So Gatsby 2.24.50 or jQuery 3.5, Bootstrap 4.5.2. Knowing the version numbers is going to go a long way to helping us figure out if there are vulnerabilities in those libraries. Because simply Google, Bootstrap 4.5.2 vulnerability, and we'll see if anything comes up. Another very useful Chrome extension is going to be Retired.js. Retired.js is going to tell us if any of the scripts, again, JS for JavaScript, have known vulnerabilities in them. So in this case, we can find that Bootstrap does in fact have, both Bootstrap and jQuery are found on the page. In this case, it doesn't actually know for sure if there are any vulnerabilities here. But if we went to refresh the page and see if Troy Hunts has anything. Troy Hunts doesn't show up with anything. Let's see this page. Here we go. So this article on stealing data with CSS. So it's using an outdated version of Bootstrap and an outdated version of jQuery. And this is a gold mine of information because it links to individual CVEs that we can go to get further information about that particular vulnerability. So it's not necessarily as clear cut as these are some JavaScript libraries with vulnerabilities and here's a link to how to hack it. You're going to have to really digest what those CVEs are, understand how these JavaScript libraries are being used within the application, but it does give you a really good idea for what possible attack vectors are going to exist. Last but not least is a Chrome extension called the CSP Evaluator. And I talked a moment ago about the content security policy. That's what CSP stands for. The CSP Evaluator is going to look at whatever content security policy may exist and tell us if there are any potential flaws in how that security policy is written. And what we can see in this page is that while things like upgrade and secure requests look just fine, we have a potential issue with script source, where it's telling us, okay, it's allowing us to do unsafe inline execution of page scripts. Other example down here is the object source is missing, meaning that if we were trying to load an object, let's say maybe a Flash file of some sort, potentially we could inject something into that object tag because the content security policy isn't well defined around that resource type. So these are three really good extensions that I use every day when I'm evaluating my own applications. And I would encourage you to download them yourselves. For what it's worth, there are a million other Chrome extensions out there that do useful enumeration in specific situations. There are specific Chrome extensions for WordPress, specific Chrome extensions for React in the world of JavaScript or Angular, specific Chrome extensions around everything you could possibly think of. There's almost certainly a Chrome extension for it. Use that to your advantage when you are enumerating an application. It'll make your life a lot easier. So let's take all of the knowledge that we just learned there, and let's explore a website called the Cyber Scavenger Hunt. This is a project that I started a couple of months ago. It has recently been adopted into OWASP as a potential future project. So as a side note, if you're interested in contributing to this project, once you see it, definitely reach out to me because I would love to have all the help I can get. But the Cyber Scavenger Hunt is intended to be a simple application that walks us through thinking like a hacker when it comes to web applications. And there's going to be a few items in here that we hadn't really talked about, but we're just going to dive right in and we'll see how much of this just immediately clicks. So number one, when we're doing the cyber scavenger hunt, we're going to notice that there are 8 steps to this hunt. And there's going to be obviously hints along the way to make this short and sweet. But the entire idea is just to do reconnaissance against a web application. And hint number 1 tells us if I were a search engine, I would look here first. If you're familiar with search engine optimization or building a commercial website of any kind, you may already suspect what the next thing is here. But if that's not clear, we'll look at hint number 2. And this is a tongue-in-cheek image from The Simpsons. Talks about this file called robots.txt. Maybe you know what that is, maybe you don't. But hint number 3, most websites have a robots.txt file. Let's go take a look at what it is. And clicking on it, we'll find the first of our 8 Easter eggs. And the reason robots.txt exists is so that search engines like Google can try to streamline the content they need to crawl in order to put your website into their search results. But as you'll see here in the comment I added, frequently developers put things in here that give away too much information. As I do here on line number 3, disallow /admin. So this is supposed to tell Google not to crawl the admin page. But if you were a hacker, what's the first thing you would do? First thing I would do would be to copy /admin and replace robots.txt with /admin. Go and see what's there. So here we find the second of our 8 Easter eggs. So yes, most applications are not going to have an admin page that's just totally open to the world. But frequently, you'll be able to navigate to a /admin page and find that you get a 403 error or something indicating that the page exists, but you may just not have access to it. So normally an attacker would spend a lot more time enumerating, but there's not a whole lot here. So let's see what our hints are for the next thing here. So we say, okay, maybe you're unfamiliar with your browser's dev tools. You can go and check out some of those links here, but we already are. So let's open our dev tools. And it says, let's go to the JavaScript console. Over here, now we found the third of our 8 Easter eggs. So developers, me especially, we're pretty lazy sometimes and we forget to take things out. So as an example, there's a console log from the admin.js file that says, what happens if we change the URL parameter authenticated, which maybe you hadn't already noticed that the application already added that up here for us, but that's set to false by default. Let's change that to true. Let's see what happens. So now we found the 4th Easter egg. Okay, so query string parameters. These are things that are easily exploited by most hackers. And in this particular case, because we're bypassing an authentication mechanism, you might consider this privilege escalation. So the idea here, if we go back to the diagram I showed you earlier, once we've escalated our privileges, we're going to go back to our discovery phase and continue enumerating for more pages on the site. And that's very clear in this case because we have a link to another page that we didn't know existed before. Click on that. Now we found the 5th Easter egg. From here, we'll let's see here. Let's go to hint number 1. If you're a web developer, you're probably familiar with status codes like 200, 301, 404, 500. If you're not, then perhaps going to the network tab in our dev tools will make something more clear for us. And hint number 3, saying this is making your header hurt. So to be perfectly clear here, the idea we're going for are the response headers from the server, in which case we'll find we've got this Easter egg header, which is the 6th of our 8 Easter eggs. And I put this in here because what you may notice is that we have all of these other HTTP headers in here, which are giving away information about my application. Just looking at this, we can tell I'm running this application out of my Amazon S3 bucket. It has various other HTTP headers, which again, by themselves may not be all that interesting or all that helpful, but we're just piecing things together. Again, here, not only am I using Amazon S3, but I'm also using CloudFront. So to a hacker, I've now exposed that, I have AWS infrastructure, and that infrastructure might become a target, even though it's not technically, part of my application itself. So the next challenge is to look in local storage, which we said was under the application tab. So if we go over here to local storage, we'll find a key value pair, which if I can make this a little bit wider, we found the 7th Easter egg in our scavenger hunt. And again, I'll tell you from experience, developers love shoving things into local storage. So this is one of any number of places where you might find data that you think is hidden, but really isn't. So from here, what about our application cookies? A cookie is another good place to store data. So where are we going to find that data? And oh, by the way, our second hint is going to give something away here. We should do a Google search for base64 decoding something. So let's take a look at the cookie. And which cookie was it? We said it was in DevTools, specifically the session cookie. So if we look here and we look at the session cookie, we see a value that looks to be, hashed or encrypted. It's certainly obfuscated in some way. So let's copy that. And we'll do a base64 decode. Website I like is base64decode.org. Paste that value in. Again, we see this doesn't look like much to the human eye, but you decode it and we find a hidden message. Now we've found all 8 of our Easter eggs. Again, sessions usually aren't base64 encoded, but tons of other data is. Base64 encoding is not encryption. So if you think you're hiding something from a hacker using base64 decoding, please stop thinking that. It doesn't actually work. Again, so that's our tour. If you would like to follow that YouTube link and learn something else, I'll happily let you do that. But we are coming to the top of the hour. We've covered very quickly how to think like a hacker when it comes to the basics of what makes up a web application. I'm going to say let's take a 10-minute siesta for anybody who has to use the restroom, or if you want to take time to install Juice Shop or OWASP Zap, now would be a good time. And then we're going to jump right into doing the Juice Shop when we come back. So that'll be at 10 after. I'm going to stick around here if anybody has questions on getting Juice Shop up and running or Zap up and running. But take 10 minutes for yourself. I've got some coffee here, and I'll see you back here in a couple minutes.
Thanks, Arthur. Arthur, there are, I think there is one more question.
Oh,
the Q&A.
there we go.
I think you answered the first two.
I
and
did.
There is one more.
Let's see here. I answered that one. All right, I'm answering that one. I answered that one. Does localhost consider HTTP or HTTPS? Localhost can do both, but you have to configure your localhost server to with the proper certificates in order to do HTTPS. That's an exercise that is not trivial. It's not difficult necessarily, but it's outside the scope of what I'm covering here today. So if you are hosting something on localhost, yes, you can do HTTPS. But that was not something I demonstrated earlier. Another question, can I get the recording? Recording is happening, and Ori, I think you said you were going to share that on the YouTube channel when it's ready.
Yes, I'm going to share it on YouTube, on AppSec.IL YouTube channel when it's ready. It'll be next week.
So here's what I'll do. Let me drop some of these links here. I'm sorry, I should have dropped these all in the chat. All right, so here's the cyber scavenger hunt I'm dropping into chat. Or hold on, that's all panelists and attendees. It should be. There we go. We get a couple of these other links out here, and then I will also drop Juice Shop and Zap. And let's go to Juice Shop. I always have to put OWASP in front of that, don't I? And then all right, you should have all of the links you need there. Apologies that those weren't shared sooner. I should also get my instance of Juice Shop up and running. So for those of you who are still out there, my recommendation is definitely to use the deploy on Heroku because it is stupidly easy to get this up and running, and it's free, and Heroku allows you to hack your own server. So there's no question about the legality of what we're doing, as I mentioned at the start of the presentation. You can run it from source using Node.js. You just clone the repo and run it locally. I'll admit that I haven't actually done that myself, so I don't know any of the pitfalls you might run into. The Docker container is also another really good option that's just really fast. You just have to, as long as you've got Docker installed, you can pull down the image and run it, and you'll be up and running in 2 minutes. So Docker and Heroku would be my two recommendations. And when you get everything up and running, should look something like this. And for what it's worth, if you don't get Juice Shop up and running today, that's also fine. You'll learn plenty as we follow along. I'll also be happy to share out the link to my instance of Juice Shop later, just so that nobody interferes with the live demo, because if you're solving challenges at the same time I am, then we're going to be in for some quirks. Ori, do you know the link to the YouTube channel where it will be shared? I guess I could just search for AppSecL YouTube, right?
Yeah, yeah, this one. I think this is the one.
OWASP Israel?
Yeah, exactly, this one.
Good point. I should also subscribe to that.
The more the merrier, right?
Exactly. We got about another 2 minutes before we get started. Again, if you stepped away, my recommendations on running JuShop are going to be either deploy to Heroku, which is free, or the Docker container. Again, you can run it via Node.js by cloning the repo, but I've never done that myself, and I will not be able to help you debug that. Same with Vagrant or Amazon EC2 or Azure or Google Compute Engine or anything else. Which, by the way, it's very impressive that the authors of JuShop have so many ways to run this thing. That's crazy.
Yeah, but it's so simple today to run a cross-platform if you understand how to automate your CI.
Right.
And if you compile it correctly, it's so simple. You can run Node everywhere today.
Absolutely, yeah. Yeah, this is a cool tool. JuShop has been something I've been using for a long time now. And like every time I get to talk about it, I am still as excited as the day that I found it. This is fun for me, so I hope it's going to be fun for everybody else here on the call as well. All right, looks like we're approximately 10 after, so we'll just jump right in. So OWASP JuShop is a broken web application that is created and maintained by a group of volunteers through the OWASP organization. This is one of the OWASP flagship products, and it is used in trainings all around the world. So if this is your first OWASP training and you choose to do another OWASP training at some point, the odds that you'll find the JuShop are pretty high. And it's because it is such a great teaching tool. It has everything from very entry-level beginner challenges all the way up through super crazy advanced things. I think there's currently more than 100 challenges to solve in JuShop. So there's a lot in here for you to do on your own time after today's presentation. We're only going to scratch the surface since this is an introductory course. But what we see here is JuShop running on my Heroku instance. And again, I'm happy to share this link out afterwards for anybody who wasn't able to get it up and running themselves. I just want to avoid the conflicts of me doing a live demo while I'm demoing. So let's take a stab at identifying what kind of application architecture the JuShop is running. And this is going to be a really easy exercise given what we just spent the last hour talking about. Just to recap, the two broad categories of web applications are, number one, a server rendered application, meaning that the web server is going to stitch together the HTML, CSS, and JavaScript when it's requested, and then deliver that as a static asset down to the browser, and the browser is just going to render it. Or we have the second category, which is a client-driven client-driven architecture, in which there are static HTML, CSS, and JavaScript files that never change, The JavaScript is simply going to reach out to APIs and dynamically transform what's on the screen at runtime. And the easiest way for us to find this is to simply right-click, go to View Page Source. What we're going to see here is not a lot of HTML code. In fact, the HTML head is about 80% of the code we have here, which is linking to various CSS files, various JavaScript files. The body tag contains an app root, and that's it. So if you had to guess which one of the two architectures this was, I'm hoping you guessed this is a client-driven architecture. And if that's what you guessed, you would definitely be right. Because as we can see, the app root is not going to match up with what our dev tools show inside the Elements tab. In fact, we can get all the way up to the body. Here's that app root tag. And then inside of that are going to be all kinds of nested HTML blocks that include all sorts of interesting looking HTML tags. If you're intimately familiar with HTML tags, you know that app challenge solves notification is not a standard HTML tag. Again, that's a pretty good indication that there's JavaScript driving the vast majority of the behavior in this application. Using our browser extensions, we can do some really quick enumeration of the juice shop. Start with Wapalizer. You see that it believes it's using whatever Zone.js is. I'm not familiar with that library, but that might be something to explore. Angular version 7.2.7, Webpack, Hammer.js, an older version of jQuery. It may be relying on AWS. It's definitely relying on Heroku. So this is a good talking point to say that Wapalizer definitely is not perfect. If it thinks we're using AWS, more than likely it's wrong in this case because I have it deployed to Heroku. So Wapalizer may not give you a 100% accurate view of what's happening in the app, but it gives us enough information in here for us to say, okay, like if you see an application running Angular, more than likely this is going to be a client-driven application. Oh, I see Heroku is using Amazon. Oh, thank you for the correction there. So apparently it is using AWS under the hood. I actually didn't know that. Wapalizer gives you a really good high-level enumeration of just the technologies being used under the hood here. Retired.js is going to call out the fact that jQuery is outdated. Again, we don't necessarily know if that's going to be useful in how we hack the juice shop, but certainly there's a lot of additional reading for us to do with CVEs relating to this specific version of jQuery. And the content security policy, there is no content security policy, which again, doesn't necessarily mean that we can hack the application by abusing no CSP, but this is just another piece in the puzzle that we're trying to build. So before we do a whole lot of other digging, the other thing that we want to do as an attacker looking at any web application is simply to look around. We want to understand very intimately what this application does, where the inputs are, where the outputs are. So let's just start clicking around here. So number one, we get this little pop-up that's kind of in the way down here, me want it. I'll just click that to get that out of the way. The juice shop appears to have a listing of products that look, like they're selling different kinds of juice drinks. And if I click on it, we'll see it's going to tell us a bit more about what this product is. I can see that there are some product reviews. It's already telling us some some usernames, or in this case, a user's email address, or what is potentially a user's email address. We don't actually know if this is accurate yet, but this is something that we would kind of jot down in our notebooks and say, okay, we're going to come back to that later. Just make sure that we're aware that it's there. We might click through a few more of these products just to kind of get a sense for what else might be in here. Don't necessarily have to click through all of them, but again, here's another potential username. Fry liked it too. So whenever you see comments anywhere in the application, whether they be, you know, in user reviews or chats, or literally the comments in the source code, if you can find, you know, somebody's name, that might also be something to keep an eye on. These are frequently things you'd find in like capture the flag competitions where, you know, Fry liked it too. Who's Fry? I have no idea, but again, that might be something that we jot down to look for later. And just click through a few more of these just to kind of get a sense for what's happening here. Maybe I could try to put something in here. It does, in fact, let me do anonymous reviews. So that's very interesting. So there's some sort of bonus that's up there. I didn't notice that before on one of these other guys. So there's some sort of bonus structure involved here. And we can page through a bunch of results. So I think it's fairly straightforward to figure out that the purpose of the application is to sell products of some sort. And you can see that there's a link to an external site on some of these products, and I'm not going to follow those because they go to an external domain. But what else can we do in the application here? So there's an About Us page that's going to have some sort of slideshow. It's going to link out to various social media locations. It has some giant amount of text that appears to be mostly garbage text. You know, if you're familiar with the lorem ipsum generated text. So this probably isn't all that interesting, except for this link that says, you know, check out our boring terms of use. And that does take us to a specific terms of use page that, again, even my browser doesn't think is anything useful. So again, mostly lorem ipsum text, nothing terribly useful there. I'll just hit the back button. And let's continue on. So I can search. Let's say I want to search for the word carrot. So I can search for different products here. That doesn't seem overly interesting, although I'll point out that the text I typed in here does appear here on the screen. It also appears as a query parameter up here in my browser. So let's say let's change this here, and let's say it's another kind of juice, orange. Let's see if that does anything. So orange up here did change the text I see on the screen here. It obviously changed the search results I have. So that's going to become more interesting for us in a little bit. So we'll come back to that. I have the ability to change languages here. I don't know that I'm going to do that right now, but that's an interesting feature. I can click Contact Us, which gives us customer feedback. So from here, it's telling me an anonymous author. Maybe I want to come in here, just write the word test, give the site a rating. Then there's some sort of CAPTCHA here. So what is 2 minus 4 minus 2? I believe that is -4. My math skills are correct. It says, thank you for the 5-star rating. Okay, so we can give feedback to the store. And then we have the ability to log in. Maybe I want to just try some default credentials. It doesn't allow us to do anything. There's a forgot password. And it does allow me to register as a user. So at this point, maybe we want to register as a user. And I don't remember if I need to use a real email or not. I'm just going to use the standard test@test.com. I'll make my password 123, PASSWORD 123. Security question. Let's see, the company I first worked for as an adult, and we'll call it test. And we'll register. Cool. So it did allow us to register as a user. And so now we have to think about the fact that we were able to navigate the site as an unauthenticated user. Let's go back to our diagram. We were discovering the application as an unauthenticated user. We've now been able to gain access to the application as a registered user. And we don't know what kind of level that user has at this point, but we're going to log in and continue doing discovery. So we'll jump right back here. It was test@test.com and password 123. We'll log in. And now you can already see that we have a new page, the Your Basket. I don't have anything in my basket right now, but we can see here there might be coupon codes or some sort of payment information. And again, normally we would just continue trying to enumerate more and more of the application. An attacker is going to leave no stone unturned. We only have another, hour and a half here in our seminar. So I'm not going to go through every possible thing, but I think we understand the idea. If you were doing this on your own, you would absolutely want to go through every possible nut and bolt here. I also have some sort of user thing I can click on where we've got the ability to do what I'm guessing is my profile. Here we go. I can upload a picture. I can add a Gravatar URL. I can add a username. Let's go back. I can do privacy and security. And whoa, what is this thing that just popped up here on the screen? This big green bar. This right here is why I love the Juice Shop. We have successfully solved a challenge, which is the privacy policy tier. This probably doesn't mean anything to the majority of you. And we're going to dive into how to make sense of this here in just a second. But just know that with every challenge we get in the Juice Shop, we're able to track the progress through all of the challenges. And I'm going to show you how to track that here in just a second. Excuse me for just one moment. Okay, so again, we would continue on with the enumeration through each one of these things. I don't need to continue beating a dead horse here. Let's cut to the chase and say, okay, where are some of the more interesting things now that we've done some enumeration? Where are we going to begin looking for the real meat of where something more interesting than, let's say, the privacy policy is going to be? Well, let's again go back to viewing the page source. And one of the first things I would start doing would be to start inspecting each one of these JavaScript files. And specifically, we're going to look at main.js. And, this looks ugly as anything here in the browser. You can see it scrolls for country mile. So that's not going to be super useful to look at here in the browser itself, but maybe I could use my developer tools. And we can look at main.js here in the dev tools. And again, this is going to scroll horizontally because it's compressed for forever. So what we're going to do is click this that expand icon, and it makes the code significantly easier to read. Now, it's still compressed, meaning that it's going to have lots of zeros, ones, and variable names that don't make a ton of sense. You know, like function U, O, A, and I. I don't actually know what those variables are. And there's still a country mile worth of code to sift through. An attacker, because they're spending 70 to 90% of their time, is going to be looking at every line of code that you have. I'm going to skip ahead and save you quite a bit of time and just go to the bottom of the file. Just scroll up a little bit. Something you may have noticed while we were enumerating the application was that the URL has this /hash mark, which also would have been a really good indication to you that this is a client-driven application. That it doesn't matter what page of the application I'm on. When I view the source code is going to be the same regardless of what page we're on, because the client is deciding what to render to the screen based upon what comes after that hash mark. So this is called client-side routing. And if the routing is controlled by the JavaScript, then somewhere in the JavaScript file is going to be a listing of all of the different routes that we can access. And in the case of the juice shop, that's exactly what we found here at the bottom of the file. So privacy policy / privacy policy, or privacy policy / change password. So that one's right here. See that changed right there. A good attacker is going to look through every link in here and say, well, what's interesting? So we're going to find, number one, there's an administration. So let's just pop that in right away. Let's see what's there. Okay. So I'm not allowed to access that. Okay. So that's fine. I'm not an administrator. I'm just a regular registered user. Let's keep looking. Recycle, register. Then we get to this one. It's called scoreboard. Well, that doesn't seem all that likely to be part of a juice shop. Let's put that in the URL. And this is going to take a second to fire up. But what this does is display all of the potential challenges that exist in the OWASP juice shop. So this is why I really like the using the juice shop, because not only does it give you an opportunity to try to hack a broken web application, but it can actually give you an interactive score to say you're finding all of the really easy targets, and it can point you in the right direction to find more advanced challenges that perhaps you didn't even know existed because you haven't been exposed to those sorts of vulnerabilities yet. As I said, this will take a second to fire up here. My browser's complaining that it's thinking too long, but I'll wait for this to load before we move on to the next piece. As I mentioned, there's somewhere in the range of 100 or more challenges here. I think it's been a while since I've updated my Heroku instance. Those of you who just downloaded this for the first time today may see more than what I have on the screen here. We see, for example, accessing a confidential document is one of our trivial challenges. That's very interesting. Error handling, we already saw the privacy policy tier. So a lot of the ones here in the trivial challenges are simply going to be things like enumeration, things that we found by accident that, again, by themselves may or may not be all that hard to exploit, but are exploitable nonetheless. So let's think back to what we learned in the cyber scavenger hunt. If we were a search engine, where's the first place we would probably go look? Well, we would probably look in that robots.txt file. And what do you know? There is an FTP folder that exists that probably wasn't linked anywhere from the application. That's just open to the world, and we just don't want Google to crawl it because Google shouldn't be crawling our FTP directory. Okay, well, this is an easy win, and for what it's worth, this is frequently something you'll find in capture the flag challenges, things in like hack the box. So go to the FTP folder, and wow, okay, here's a listing of all sorts of things that we weren't supposed to find because, who would go looking for FTP things on the web? Well, what do we have in here? We've got things like an Easter egg, some sort of backup package.json file, some errors, there's an acquisitions document. Yours doesn't show a robot.txt. It's robots with an S. Let me just type that in here. It's not not an uppercase. That should be a lowercase r. So there could be all kinds of things in here. And if we look at the acquisitions document, okay, so this document is confidential, do not distribute. Well, we were able to access it without very much trouble. So if we go back to the Juice Shop homepage, it's now going to tell us we solved that accessing a confidential document challenge. So again, enumeration is the name of the game. And now that we've done some enumeration, we've learned a bit about the application, let's start to explore some of the more advanced things that an attacker is going to begin looking for as they have found some of the items that we've already found. So I'm going to log out and let's take a look at Apple Juice. All right, so we saw that we think there is an administrator's email here. Well, let's copy this and let's log in. Now, the first thing we might try to do would be to brute force some passwords in here. I could say, just use the word password, all lowercase. It's invalid. Maybe password 123. That's not it. Maybe password 1234. That's also not it. Okay. Brute forcing can be hard, but if you have a list of very common passwords, it can be pretty easy to do. What if I tried admin, ADMIN? Let's try that. That's not it. Admin 123. That actually works. So I'll drop that here in the chat for the password there. But we can see that vulnerability there is effectively not having a strong password policy. And if we're able to guess the password of any user, let alone the administrator, that is really, really bad. Stupid question, but how do you decide when to remove the hashtag or not? The hashtag in the URL. If you want the application to refresh the page, get rid of the hashtag and then hit enter, and it will force the browser to refresh. If you leave the hashtag in there and you type anything, you'll notice that the page does not do a hard refresh. I can type anything in here and the entire browser is not going to refresh. The client-side JavaScript is always watching for this hash and anything that comes after it. And it's going to catch when the hash changes and prevent the browser from refreshing the entire page. So if you take away that hash, the client-side JavaScript can't detect that the hash changes. And so then the whole page refreshes. So now that we are an administrator, we could do any number of things. But again, we would probably go back to our discovery and continue enumeration. I'm going to skip that. I'm going to log out. And what we're going to do is try to log in as that administrator again using a different mechanism. Now, for those of you who are familiar with SQL injection, this will be a really easy hack for us to exploit. If you're not familiar with SQL injection, I'm not going to get too deep into the weeds because SQL injection could be its own 3-hour seminar in and of itself. The gist of SQL injection is that we expect to possibly run some raw code in the database query itself so that we can change the database query on the fly. So what I might try to do is do a very bad attempt at SQL injection so that I can get an error message. So this might just be simply adding a single quote, a space, and then maybe any text I want to. So doing that didn't change a whole lot here, but if we open up our DevTools and look at the network tag, and let me run that again. Let's see here. I get, oops, not what I wanted to do. It gives me an invalid email or password. Let me add a semicolon in there. What I'm trying to do is to force an error. And, oh goodness, here we go. 401 unauthorized. I don't know if I can actually do this on the fly. And I'm not getting a good error message despite my poor attempts at a SQL injection. But let's say for a moment that I wanted to do a very standard SQL injection. I'm going to type this into chat before I type it in myself. So it's going to be a single quote followed by a space, the word or, space, 1 equals 1, semicolon, space, dash, dash, space. And it converted my 2 dashes into a long dash. It's important to have the space at the end. But if we do this, and you know what I'll do, I'll go into my console and type this so you can all see it. It's single quote space or 1 equals 1, semicolon, space, dash, dash, space. Taking that, and logging in, gives me an unauthorized again, and that's interesting. I wonder if I try that in the email field, if that will work. What do you know? It did successfully log me in. And the reason that this works is we were able to inject, we were able to inject this code into the raw SQL command that gets executed against the database. So it's bypassing the fact that I didn't give it a valid password. The 1 equals 1 always equates to true. So basically that login attempt, maybe this is going to be easier for me to show with an error message. So let's do a bad SQL injection here. I can enter anything in the password. Okay, so now if I go to my network tab, we'll be able to see the raw SQL command, and it'll be more clear why this worked. So the error message we get is select star from users where email equals, and then you see that their command starts with a single quote. And then what we gave it is the single quote, and I omitted the or. Because I omitted the or, it's throwing the error here because it's bad SQL syntax. But we can see that it's trying to put whatever I gave it inside the single quotes that already existed. So we're able to escape that command using this single quote and then execute whatever code that we wanted to. So we were able to log in to a user, again, providing the or in here. And it doesn't care what password we give it because it's saying any user that equates to true, which is basically saying, give me the first user in the database. So that allows us to run Sql injection here. That logged us in as admin, unfortunately, for this application. But it could have been a root user. It could have been conceivably some generic user. But this would be a really easy SQL injection to run on the application. We also saw how to generate an error. And the error in and of itself is clearly a vulnerability because it's telling us what the raw SQL command to the database is. So if you are able to force an application to give you an error message, you can learn a lot about that application just by reading the error. Number one, you're going to understand what kinds of commands are being run against the database in this case. In some cases, you might get very detailed information about the database itself, whether it's running MySQL or Oracle or I don't know, some other kind of database. The point stands that the more you know about the backend and the database layer of the application, the more likely you're going to be able to find examples on how to exploit it. Let's see here. So let's take a look at registering a user. And let me close that and reopen it. Okay, so let's go to the login screen. It's not yet a customer. I'm going to keep my network tab open here. And let's do a test one at test.com. Let's do a password of password again. And let's do my same company I worked for with test. And we'll register a user. And if we look at what we sent over the wire, so we can see our request headers. More importantly, we see the request payload down here. We'll see what we sent. And if we look at what the response was, we'll see there's this data object created at email. Interestingly, there's an isAdmin flag on here, which tells us it's false. This would be something that would catch my eye as an attacker to say, well, when I sent the data, I sent an email, a password repeat, a security answer. I wonder what would happen if I sent with that request an isAdmin flag. So I'm going to copy this as a curl. I'm going to come into my editor real fast. Let's create, new file. Let's call this curl.txt. I'm going to do this just so it's easier to edit. So let's say number one, I already have an email of test1. So let's change that to test2. Password and everything else can stay the same, but I want to get that is admin. Let's just put that first. So let's add a space. Let's say is admin true. And then let's copy this whole thing. Let's clear my terminal. Let's paste it. And you can see in the response down here, I have a success. And is admin down here is in fact true. If we come back to the application, we can see it's already told me I've solved another challenge. I'm able to register a user as the admin. So again, that was test2 at test.com. And my password was password. And I can now log in and trying to see if there's an admin, let's see here, an admin panel we can get to maybe. I don't see a link to it, but I do remember earlier there was an administration link that we found looking at the JavaScript file. So now if we come to administration, you can see that we have the ability to do anything an administrator of this site would do. In this case, we might be able to look at different users. You can look at different kinds of customer feedback. So there's all kinds of fun things we can do. And again, now that we're the administrator, we're going to continue doing more and more discovery. Got maybe one more challenge that we're going to do here, and then we'll take a break and then come back with OWASP Zap. So let's take a look at that search functionality. We were looking at the ability to search for a product. And I called out that not only does whatever you typed stay there, it now appears in the URL and it appears here on the screen. Whenever you see user input that is reflected back to you on the screen, that should raise some red flags to you as the potential for things like cross-site scripting. And you can achieve cross-site scripting in any number of ways. And the inputs can come on any number of pages in the application. Some really interesting cases are like we see here with the search term being reflected in this top area. But it might also be available to us in things like customer reviews. It might be in the username that the user registers with. If the application does not do a good job of sanitizing the input when it gets stored in the database, but also when it is reflected onto the screen, there's tremendous potential for vulnerabilities like cross-site scripting. And as an example of this, I might create a payload. Let's do that here in my IDE. So I've got some bigger text. But if we wanted to force a cross-site scripting error, one really good default payload we might use is something like an image tag, where it has no source attribute, but it has an on error attribute. I'm going to close the tag. So the on error might contain some code. And for lack of a better example, let's just do XSS for cross-site scripting as our payload. And we'll copy that. I'll put that directly here in my URL. And if I hit enter, we'll see that my JavaScript alert was executed and that it did print XSS in the alert box. So the search results here clearly are vulnerable to cross-site scripting. And even if I inspect this element, you look at the search results, and inside of that span is exactly what I typed up in my URL. Even though it's URL encoded up here, the browser does not protect us from that inside of this particular vulnerability. So to mitigate that, the web application in the file that controls putting the search term inside of this element here on the screen, it should do some sort of escaping to make sure that HTML elements can't be added directly to the page. A more realistic example might be, instead of using a JavaScript alert, I might, I don't know, do something like document.cookie. Actually, I am going to alert this just to see if it works. Here we go. So it's going to alert to me all of the information contained in my cookie. So if I'm able to alert this, something that something that an attacker might do would be, instead of just alerting your own cookie, because that's not all that useful, if you were able to put a persistent cross-site scripting attack, or even in this case, if I could give this URL to somebody who I knew was logged into the store, instead of alerting the document.cookie, could I send that cookie value to some remote server so that I could find any user's cookie value, and then I could log in as that user by using their cookie? That would be the attack vector to work with in this case. So obviously, cross-site scripting is a critical vulnerability, and this is one of several places in this application where cross-site scripting vulnerabilities exist. So we're 5 minutes from the top of the hour. I'm going to say let's take a 5-minute break, give everyone a chance to install OWASP Zap, maybe use the restroom. And what we're going to do when we come back is begin enumerating the juice shop using OWASP Zap and get a sense for how automated tools can do all of the things that we just spent the last 2 hours talking about so much easier and so much faster. So if you have any other questions, feel free to drop them in Q&A or the chat. And I'm going to go use the restroom, and I'll see you back here in about 5 or 6 minutes. got about another 2 minutes here. Were there any other questions, or did anybody need help getting OWASP Zap up and running? Yours is still copying to the applications folder. Okay. Yeah, you should be down in the next little bit. It shouldn't take all that long to do. Okay, everybody, we are back. And as I said, installing Zap shouldn't take all that long. I know it's not the smallest application in the world, but it shouldn't take all that long to install and start up. When you're first starting up OWASP Zap, it's going to prompt you. It's going to say, do you want to persist the session? In this case, I'm going to click no. Feel free to click another option if you want to, but basically this just means it's not going to save what I'm doing after I close OWASP Zap. So there are multiple ways in which you can use OWASP Zap. I'm going to show you the way that I prefer to use it. I know different people have different preferences, but the first thing I'm going to call your attention to is all the way at the bottom. It says primary proxy, localhost port 8081. It may or may not be the same port on your machine, but in my case, that's what it defaults to. I think that's usually the default option for it. So depending on what browser you're using, what we're going to do is change the proxy settings of our browser to utilize that port so that it can funnel the traffic from the browser through OWASP Zap, from the server through OWASP Zap and then down to our browser. And I think I have a diagram of that to kind of demonstrate here, where, so requests go from the browser through Zap up to the server, then all the way back down. The server response comes through OWASP Zap and then and ends up in our browser. In this way, we are able to see and persist all the information about the application that we are targeting. So in order to do this, we've got a couple of options, and I'm going to fire up Firefox because Firefox has some interesting proxy settings that I prefer over Chrome, but you can easily do this in Chrome as well. Number one, if you simply wanted to go to your preferences and you search for proxy, you could come into your network settings and manually configure a proxy. Alternatively, you can use a Firefox extension called Foxy Proxy. I think there's actually two of them. If you do a Google search, there's Foxy Proxy, I think Lite, and then Foxy Proxy Regular. And either one works. But what's cool is that you can configure multiple proxies. In my case, I've got one for Burp, I've got one for OWASP Zap, and they're set up the same way, where we can change the proxy type, where it points to, and what port it is. So for the purposes of this, I'm going to encourage everyone to use Foxy Proxy if you're using Firefox. So there's standard and there's basic. They both do exactly the same thing. The reason I like this in Firefox instead of Chrome is that Chrome will send all of your browser traffic, or sorry, it'll send all of your, I think it's all of your host traffic through the proxy, whereas Firefox will only send the browser. I'm not entirely sure if that's still true. That was true 2 years ago when I first started using this. But if you want to use Foxy Proxy, these are the settings you would do. You would select HTTP proxy type, point it at your local host, and then whatever port that OWASP ZAP has down here at the bottom is the one you want to point it to. Again, if you're doing it from your other browser settings, it's going to be exactly the same. And in Chrome, if we go to settings and I search for proxy, in my case, it actually, I still have Foxy Proxy installed in Chrome. So you can set the options there too. So if anybody has any questions, I'm happy to continue answering those, but let me just push forward here using Foxy Proxy in my browser. So I'm going to go over here. I'm going to turn OWASP ZAP on. And the first example I'm going to go to is that same cyber scavenger hunt that we were looking at before. And somebody's lost. They're on Chrome. Sorry, let's do this one more time here. If you go to your browser settings and we click for proxy, now in this case, it knows that I'm using Foxy Proxy as my Chrome extension. However, I forget where the default setting is in Chrome. So if you're not using the Foxy Proxy extension, you see it's under network. I don't see that. I think because I have Foxy Proxy installed. But coming back to my Foxy Proxy settings, this is going to be the same as any place that you set your proxy settings. It's proxy type HTTP, pointing at your local host on the port, and there is no username or password. So when we have that set up, so I can see that Foxy Proxy is pointing my traffic to OWASP ZAP. If I come into OWASP ZAP, we're going to see that it starts to collect various information for all the traffic coming through my browser. What I'm going to do is I'm going to highlight cyberscavengerhunt.com. I'm going to say include in my default context. I'm just going to click OK. And then there's a little bullseye that's right here on the left. And I'm going to click that, and it's going to filter everything I have in OWASP ZAP down to just the site that is in my context. The same is going to be true down here in this bottom panel. You're always going to see this little bullseye. So if I filter that to just what's in my context, it's going to make this a lot cleaner for us to look at. OWASP ZAP is already beginning to enumerate my site. It's building a sitemap of all of the resources that are included in, oops, we're looking at Firefox, it's including all the resources that it confines. And yes, we're going to be using JuShop in just a second. I'm going to be doing a quick demo using Cyber Scavenger Hunt because it's significantly smaller in scope. So to give you a tour of OWASP Zap, there's 3 main tabs. There's like our left top pane, which is going to contain the sitemap for any site that we're enumerating. You've got an upper right pane, which is going to have all information about things like the request and response that gets made for whatever we click here on the left. And then on the bottom, it's going to tell us what the history of requests are that we've made, maybe give us any alerts that are relevant to the application that we are enumerating. And there's all sorts of other things that I'm going to get into here in just a second. The first place you're going to want to start when you are doing your enumeration is going to be this sitemap up here on the upper left. And exactly as we did before, we could manually click through the application. And as we discover new pages, they are going to appear here in our sitemap, which is incredibly useful because then we don't have to remember or physically write down all of the different pages, assets, resources that are being requested by the application. OWASP Zap will take care of that for us. OWASP Zap can also do a variety of other things that are going to automate this process for us. So if we click on this plus sign and we go down to Spider, we can spider the site using a new scan, only include, I should probably start at the root, only include things that are in our default context. And I can go ahead and start the scan. And what we're going to see is that it automatically goes to find new pieces of the application for me. It's not necessarily going to find everything. It's going to find things that it can physically spider following links on the page or links in things like our JavaScript files. But it's going to find a lot of things for us. Similarly, there's an Ajax Spider. I can do the same thing. Let's select my default context to and then just start my scan. And oh, let me try that again. Let me use headless Chrome. I don't know if I have headless Firefox installed. So it's going to go out and try to follow any API requests that may exist from my JavaScript files. In this case, I don't know that I've actually found anything new, but just know that that's there. And we will be using that with the JuShop. Last but not least, I'm going to show you this thing called forced browse. And if you're familiar with tools in Kali Linux like GoBuster or Derby, things that are going to do brute force enumeration of a web application, that is exactly what the forced browsing feature in OWASP Zap does. And you can give it, let's say, like a directory list, and it's going to try to attack, or sorry, it's going to try to enumerate any directories that might just be hidden based on a word list that you can give it. And I'm going to go ahead and do this. And what we're going to find is that my application, the Cyber Scavenger Hunt, is returning a 200 response for a lot of different resources, which is giving us lots of false positives in this case, partly because it is a client-driven application. And if we go back to the home page here, we'll find that if I type in something like /education, it's still going to render the home page for us. So we want to be careful when we are doing enumeration of an application that's client-driven as an architecture, because it's not going to give us things like, 500 errors or 403 errors that might say that I couldn't find a resource. So be careful, because that might, as it did in this case, give me so many false positives that my source tree here in Zap is now almost unusable. So you want to be very careful about using this feature if you're using a client-driven application. If it's a server-driven application, it'll be a lot more useful, because you're unlikely to get 200s for basically everything that it looks for. So a couple of questions here in the chat. We've got, does it follow the instructions of a robots.txt, or is it Spider the whole site? That's a good question. I'm pretty sure it does not automatically follow robots.txt, but I'm not 100% certain on that. I would have to go back and read some of the documentation on OWASP ZAP to know that for sure. Second question was, does the word list come with Zap, or do we need to feed it? So this word list does come with Zap by default. However, you can give it a completely different word list. And so as an example, clicking on that settings icon, you can come in here and you can select a file, which brings up a file prompt. So again, if you were using a system like Kali Linux, it's going to have tons of word lists installed in Kali Linux by default for a bunch of different tools. Alternatively, you either come up with your own word list, or you could download one from the internet and then feed that to the forced browsing feature here and use that instead. You can also do things like choosing file names to ignore, or file extensions to include. So there's all different kinds of options that you can use to configure. And again, OWASP ZAP has lots more tools than we're going to really have time to get into today for just an introductory course. But I would encourage you to explore some of these more if you find this useful. One other last point that I'll raise is that OWASP ZAP does have the ability to install different extensions itself. So just like Google Chrome has extensions, Firefox has extensions or add-ons, OWASP ZAP also has add-ons. And one of those is the same thing that I showed you earlier, which was Wapalizer. And so adding that to Zap has the benefit of showing you and remembering all of the different technologies across the site, not just on each individual page, where if I'm on Google Chrome, Wapalizer is not crawling the entire site to tell me what's involved here. It's only looking at this one page. When you have it installed in OWASP ZAP and you're going between different pages, it's going to remember all of the technologies there. So it's kind of a one-stop shop. You don't have to go and, again, write these down manually. But we're not going to use that too much here today. I just wanted to point out that does exist. So what I'm going to do now is I'm going to remove, well, no, we'll do. We're going to navigate to the juice shop. And I'll let that load. Well, notice that because I'm filtered by my target, that it doesn't appear. But if I come back down here, I can now include in my default context. Hit OK. And then refilter. Now the site exists again. So from here, the first thing I'm going to do is I'm going to perform another spidering operation. Start that scan. question is, what is the context name? So you can create different contexts. If I wanted to create a new context, I was simply adding it to the default context. It's just a way of separating groupings of targets. So if you were doing, let's say, a full network penetration test, you might group different web applications or different websites into different contexts so that when you go to do things like spidering, you can limit the scope of which targets you're spidering. So it doesn't really matter what you name them. It's just a way of grouping them. And in fact, what we'll see while it's doing its spidering, it's saying that it's finding like links to OWASP.org and it's considering them out of context. So it's not going to continue spidering down that domain. It's just going to stick with things like, so, you know, it already found the FTP directory. So more than likely, there was either a link to the FTP folder or maybe it did actually follow the, you couldn't add the Heroku app link to the sites. Which option did we use? So if you come over here, you're going to right click and just include in context. In my case, I was able to do default context because it wasn't already in there. You know, if I came to let's say the site, I would just include it in my default context. And then when you come to Spider and you do new scan, you're just going to select either default context, or you could select just the domain itself. And then the rest of these you leave as the default and just hit start scan. Same thing we're going to do for the Ajax Spider. Or again, if you either want to start with your default context, or you could click on the domain. Why it won't let me select that, but we'll just do default context, which is already selected, by the way. So from here, again, I'm going to run headless Chrome. You could select any of these, although they may just depend on what you have installed. So if they are inactive for you in the starting point, it may be because you already have context, default context in here. If I were to clear this out, I suspect now I can select that, or I could select, oh, it's interesting that it doesn't let me select that. I bet if you were to just find the, is there an index file in here? Yeah, your best bet is just to select default context. And if that doesn't work, like I said, hit cancel, clear out this box, and then reopen it and select. And then we're going to hit start scan. Again, this may take some time. We'll see what it finds. I am not going to do forced browsing because we know that this is a client-driven application, which means that as I type in random gobbledygook up here, while it may render me an error page on the client, or it may not, it certainly is not going to give me a 404 or a 403 error code, something that Zap would know to ignore from the source tree. So we'll let that do its thing for a minute. But from here, let's pivot over to the alerts tab. And so we have this filtered down by our list of sites in the default context. See if I can make this a little bit bigger. Can I? I can't make that bigger, but what the alerts tab is going to do is going to give you an overview of known vulnerabilities mostly according to the OWASP top 10, but potentially in line with other security best practices. And so we talked about very briefly the idea of content security policies. And what this is saying is that it's flagging on multiple things the fact that we have a wildcard directive included in that content security policy. And so we'll see that as I click this down here, my response tab changed up here. So we see that the content security policy is included in our HTTP response headers, but it's saying it has some problem with that here. And it has a little bit of a description. If you scroll down here in Zap, it'll offer you a solution, perhaps some references to go do some further reading. As I've been saying all along, just because it's flagged as a potential security issue or a potential vulnerability, it doesn't necessarily mean that there is an active vulnerability to your site. These are alerts that should be given to the developer of the application and saying, hey, can we close whatever issue this is? Can we add some piece to the content security policy in this particular case so that this alert goes away? Or is this a risk that we are simply willing to accept as an organization? The reason why you might want to mitigate whatever alerts are appearing here in OWASP ZAP versus simply accepting them is to an attacker who's using the same tool that you were using, the more things that they find, the more puzzle pieces that they're able to put together, the more likely they are to continue trying to attack your application. If an attacker comes to your web application and has a hard time finding anything, they are very likely to simply give up. So the more of these items that we can close and the fewer of them that we can give away to a potential attacker, the more secure our application is going to be. Number one, because we've closed all of those issues, but certainly number two, because an attacker is going to grow frustrated pretty quickly. An attacker wants to find things. They want to break into your application. And if they can't break into yours, they'd rather go look somewhere else. Other items in the alerts that we might be interested in are going to be things like private IP addresses that might be disclosed. And I don't know why Zap is freezing on me here. It should be clicking there, but my application is not very happy with me at the moment. Let me try to forcibly close it and then reopen it. Let's try this again. Okay, so I'm going to, again, come over here, add to my default context. Hit OK. I'm going to filter this down to the list of things in my context. Same thing over here with my alerts. I am not going to restart my my spiders. I think that may have been why this was lagging on my machine. But we kind of get the idea here. So Zap is going to remember all of the things that we found. It's going to alert us to things like private IP disclosure. If if my computer ever catches up to me here. Oh, this is unfortunate. What else is on my computer right now? Force quit. Let's force quit that. Let's force quit text edit. Let's quit Slack. Let's force quit that. I'll even force quit Chrome. That's the ticket. All right. Maybe that was the ticket. So we can see that in the background here, there's a private IP that's been disclosed. So this would be something that obviously we would want to make sure didn't exist in our source code. There might be things like suspicious comments that are left in JavaScript or CSS or HTML. Those are absolutely things that we're going to want to look for. So it'll tell us in what files those suspicious comments exist. Because again, if there are tens of thousands of lines of JavaScript running a site like the Juice Shop, then being able to quickly narrow down any items of suspicious nature will be really, really useful to us. So let's take a look at some other advanced features that we might be able to use in OWASP Zap. So beyond obviously spidering sites, doing brute force directory browsing, OWASP Zap has a bunch of built-in scripts, which can be really helpful to us in enumerating an application as well. And as an example here, let's take a look. I think at one point, and I don't know if it's still in here. Okay, so it did not save my my last session. We can do things like create scripts that look for specific keywords in any of the resources that Zap is trying to identify. So as an example, the one I had tried to prepare for us is going to be let's see here. Right. So if we were to try to open a new HTTP, or sorry, a new script, I came over here and the script console. Here it is, the new script. So I can call this maybe AWS things. It's going to give us a lot of different options for what kind of script we want to create. And in this case, we might want to do a passive rule. And the script engine, we have different options here. We could write our script using JavaScript. There's a scripting language called Zest, which is very popular here in OWASP Zap. Or we can use Python to write a script for OWASP Zap. And if we want to vote on start, we want to enable it, that's fine. And so we'll call it AWS things. And let me just double check, see if I can find the one I had done before. Not under there. That's okay. Our active role maybe. Oh. All right, so what we end up doing is over here in our window, you can see that we get a default template for using Python. So it's got an applies to history type definition. It's got a scan definition. And what we would end up doing in here is to say that this scan function will get called automatically. So we don't have to do anything other than just define that this scan function exists. It takes a couple of arguments in here. And the idea is that we would replace this block of code with the ability to raise an alert. And if I'm doing this correctly, and we just start navigating the site again, because it's always going to equate to true by default here. This should be creating an alert with a passive vulnerability title for every HTTP request that goes through. So this is going to be very useful for us if we have very specific items that we are looking for. And we could say, as an example, if we wanted to parse the HTTP responses for very specific keywords, things like AWS keys, that we would raise an alert here in Zap so that we could immediately go look for those things if that was something we were particularly interested in, or perhaps the word password, if the word password appeared anywhere. And I had found in my travelings an example of this using AWS keys that I thought I had saved. Apparently I did not. Perhaps this is it. This definitely wasn't it. But you'll also notice that there are lots of GitHub repos that have different scripts for us to start using. So as an example, basic spider scan, or let's see, here's I don't see AWS in here, but let's say maybe you wanted to look for, let's find one that looks interesting. Let's look at what Wapalizer does. So Wapalizer, this also is not a good example. I apologize. I can't for the life of me think of where this example was. See if we can do this on the fly here. What I believe we can do is to say, something to the effect of if message dot get request body dot includes something like AWS. In that case, execute our ability to raise an alert here. And naturally, we would change the name of this to AWS found, the full description, and then you can add in whatever parameter was found and other information about this so that it populates our vulnerability pane down here in the bottom correctly. So I can save this and then attempt to reload it. It's not going to find anything in this case because I don't believe it's finding any AWS things in the juice shop. But that would be the way in which we could use these scripts. And as I mentioned, there are lots of places on GitHub specifically that have a lot of these things already written for us, which is really, really useful. Again, things like finding passwords, finding AWS credentials, parsing HTTP responses in any which way. Clearly, if you're doing some sort of internal testing and you're interested in one specific attack vector, you might create your own script in order to do that rather than having to rely on something that somebody else wrote. But this is the way in which you would use these scripts. At this point, we've got 20 minutes left. I know several of you have had to dash to other presentations that are still happening in the event today. I wanted to leave some time at the end here for as many questions as possible, because I know that I was jumping really quickly through different items. I definitely didn't dive deeply into a lot of different areas. So I wanted to give an opportunity for lots of questions so that I can help dig into the areas that you might be finding I didn't dig into today, or that you are particularly interested in. So let's open the floor. Don't be shy. Hopefully you're all typing furiously.
Now, do you want also to allow people to raise their hand and ask the questions?
I was thinking more they could just either type into the Q&A box or the chat box. I'm happy to monitor both of those.
Okay. I mean, anyway.
I mean, they can raise their hands too as well if that's helpful. If anybody needs me to post those links again, I'm happy to do that. I don't know what happens when people join or leave, if they're unable to see the links from earlier in the chat. If 27 of you are just going to hang out in the background with no questions, I'm also happy to go and do another couple of challenges in the juice shop just to help you get your money's worth out of the 3 hours.
Yeah, maybe go for it. Maybe it takes like 10 more minutes and then we can close it.
Sure. One question here is, they arrived late. Can we share the presentation? The presentation is being recorded and will be available on the OWASP Israel YouTube channel, likely next week. So if you want to keep an eye on that YouTube channel, that's where this presentation will be posted when it's available. I'm sure there'll probably be a follow-up email from the event as well that may include that link. All right, so let's go back to the scoreboard. I mean, let's see if we can find anything that looks particularly interesting to us. So repetitive registration, the derive principle. Can we register a user that already exists? That seems like an interesting one for us to do. So let's take a look at that one, and then let's look for the devastating 0-star feedback to the store. I think both of these will be really kind of fun for us to look at. So let's jump back to, first let's log out, and then we'll come back to the registration here. So we had, I believe, one user I tried registering was test@test.com. Say password 123, password 123, and the company I worked for was Test. And if I open my my network tab in Chrome DevTools, hit register, the email must be unique. So that's interesting. Let's take a look at what got sent there. Let's get rid of the response headers. Let's look at what the request was sent. Request was sent. I don't know. There's a whole lot interesting in the headers, but we can certainly look at the post parameters that were sent. And where are those? In here we go. The request. Here we go. So we've got an email. We've got a password. Security question. I guess the question is, how do we get around this here? So we might simply try to duplicate this request and do things over curl to see if there are ways that we can futz with some of these parameters here. What was the response here? The email must be unique. So let's copy this as a curl. And oops, I closed my my Visual Studio Code. So let me reopen that. Let's look at this. So this is the request that got sent. And if we go back to the payload here, so I'm just curious if I just copy this and run this out of my terminal, let's see what happens. So we still get the same validation error. Email must be unique. So that's curious. I wonder if we, change some of the items that we're sending here. So if we take off the create of that and the update of that, let's see what happens when we send that one. So it's still telling us email must be unique. Okay. I wonder if when we did this the first time, or not the first time, but in one of the earlier examples, we added the is admin flag and set that to true. Let's try sending that, see if it makes a difference. Oh, that didn't change anything. I wonder what happens if we continue altering this. I wonder what happens if, oops. I wonder what happens if we take out the email altogether. Let's clear this and try sending that. Interesting, we get a success. And we've created an admin with no email, so that's super interesting. If we come back to Juice Shop, and let's go to the scoreboard. I wonder if we solved the duplicate user, or maybe if we solved a different challenge entirely.
So in our case, we did not solve repetitive registration, but let's see here. We registered an admin user. I'm pretty sure that was the challenge we solved. I don't know which one it was. But, you know, we would have to continue trying to get a duplicate user there. I'm having a bit of trouble doing that here on the fly, so I'm just going to move on to a different example. Let's look at giving a devastating 0-star feedback to the store. This one I think will be a little bit easier for us. So again, if we go back to the main page, we saw that we could give feedback. Where was that? Was that under Contact Us? And we could leave a comment. If I don't select a rating, let's try, what's 5 plus 5 plus 1? That should be 11. We'll see that it doesn't actually let me click submit. So there's two things that we could try to do here. Number one, if I inspect this element, we'll see that this item is disabled. Let's just edit the DOM on the fly. It changes the disabled state of this button. Now I can hit submit. And now it did actually allow us to, you know, submit that. And it allowed us to do a 0-star rating. So that's one way to have solved that challenge. Another way actually would have been, if I copy this as a curl, if I had simply given a feedback of any kind and then copied the rating, you know, like as an example, if I had, you know, typed in whatever, clicked a 5, 3 plus 1 is 4, minus 9 is -5, and hit submit. So I could copy this one, come in and modify. So we see we give it a 5-star rating. I had simply changed that to a 0, copied this request and replayed it. That also would have been a good way to do this. If we're using OWASP Zap, and I see somebody asked the question about Burp Suite to modify the request as well. You can use Burp Suite. I did gloss over actually doing that here in OWASP Zap. So we can see here's that feedbacks request in our history. I can come into here and open resend with request editor. And that will pop open a window over here where we can see exactly the same curl request that I did before. Maybe give that a 0 and then hit send. And we'll see that it's a success. I could try posting in like a -100. We'll see if that works. See, that also was successful. So you can use OWASP Zap as well to do this. If you're familiar with Portswigger's Burp Suite, OWASP Zap is effectively the same tool. They both will configure an application tree for you over here in our Sites tab. They'll give you all sorts of alerts. You can inspect request responses. You can spider the site. You can replay requests. The core difference between the two is that Burp Suite has two versions. They've got, you know, the community version, which is free, but does not allow you to do the vast majority of things that you can do in Burp Suite Pro. Burp Suite Pro has a license fee, I think, of $300 a year or so. It's definitely worth the price if you can afford it. However, OWASP Zap does all of the same things that Burp Suite Pro does. The interfaces are slightly different, but, you know, 99% of the things that Burp Suite Pro does OWASP Zap does as well. It's just the difference between an open source tool versus a proprietary tool, and not knocking Burp in any way, because Burp is, like I said, it's worth every penny. But you know, if you get comfortable using OWASP Zap, you'll never have to pay for it. Keep posting any questions that might come to your mind. I'm going to see if I can't do one more challenge that I'm unprepared for here in the juice shop. So let's go back to our scoreboard. And let's see here. So I believe I showed us the reflected cross-site scripting attack. I'm pretty sure this was the one we ended up using on the search. Although I think you have to replace these backticks with single quotes for this to work. And let's hit search. And there it is. And maybe I did have to use the backticks. I don't remember. It's a bit finicky with, there it is. So now it gets the reflected cross-site scripting attack. We go back to the scoreboard. There was another challenge for a persisted cross-site scripting attack, or a DOM cross-site scripting attack using effectively the same payload here. So let's see where I might be able to stick that. I wonder if in all of the places where we allowed user input to the application, we could register a user. So let me just quickly kind of go through the places that things could be. The email we know appears as the default username for any user. So if we were able to register a user using this, which is going to tell us that's not a valid email address. So potentially that's not the place, unless we could bypass that request using either curl or OWASP Zap to replay the attack. That might be one angle. Another angle is the customer feedback, where you put in your comment. Now, that didn't appear to most users. It might only appear to the administrator. So that might be an angle. Another angle might be the customer reviews. I wonder if we were to type this in here and submit it, what happens? So it's obviously not in the customer reviews, because this did not execute a cross-site scripting attack for us. So potentially, let's try the customer feedback. Let's just add this. 5 plus 6 is 11. Minus 7 is 4. So we submit that, and then let's log in as an administrator at test.com. Password 123. Let's go to the administration. Did that not work? What was that? What was that URL? I'm probably just misspelling it. The debugger tab, main, make it pretty print, scroll near the bottom. And here we go. Administration. My This user may not be the admin. No, that's right. Test1@test.com. Test1@test.com. Is it just password? Here it is. And maybe you are the administrator. What? Just hack our way in here. So I know I'm the administrator. Administration. There we go. So from here, I wonder if, let me just close my DevTools here. Let's delete some of these comments here. I don't actually see any of the feedback that was submitted a minute ago. It's curious. Unless maybe it was down in here. And I don't actually see anything in there. So that's curious. I wonder if I can, oh, now there's a complaint. Let's try adding the payload here. So this was an image source on error equals alerts backtick XSS and submit, and then go back to administration. I still don't see that, so that's curious. Well, I guess that must not be the place either, where this particular input goes to execute that DOM XSS. So again, we would just continue enumerating the site until we found the right input to add that to. Still have 23 people on the line, and we're now at the end of the 3 hours. Any other questions that anybody has thought of along the way? Let me give another 2 minutes to see if somebody types a question. Otherwise, thank you very much for attending today's presentation. I hope, in spite of some of my technical difficulties, that you were able to learn something useful. I know you probably still have lots of questions, so if you don't feel comfortable asking them today, or if you don't think of them until later today, tomorrow, next week, next month, definitely reach out to me. The best places to find me are going to be either on Twitter, which my handle is Arthur AK. Let me turn off Burp Suite so that. Why is a restart required? Really, Firefox? I can't win today. Jeez. So twitter.com/ArthurAK is my Twitter handle. If you're not on the Twitters, aka webdesign.com. And you can hit the contact me link over here and just fill out the form. It sends me an email. I'm happy to respond to any and all questions. So again, thank you very much for the time, and hopefully I'll see you at the next event.
Thank you very much, Arthur. We highly appreciate your time and effort. It was really good. Thank you.
Thank you, Ori. Thank you, everyone.
Bye-bye.
Is there any other wrap up you need from me, Ori?
No, we are done. Thank you very much.
You bet. If there's anything else I can do, please reach out.
Of course. We'll stay in touch. Thank you.
Thank you.
Have a great day. Bye.
You too. Bye-bye.
Bye, everyone.